Alright, now we're going to talk about adding or subtracting rational expressions with unlike denominators. So anytime you're adding or subtracting fractions, you must have an LCD. You do not need a common denominator to multiply or divide fractions, but you have to have one when adding and subtracting. So when you're going to work with fractions, make sure you know whether you need an LCD or not. Multiplying and dividing fractions, you do not. Adding, subtracting, you must have a like denominator in order to be able to combine them. So the first thing we're going to look. So we're going to look at this and say we have two fractions that we're subtracting. So in order to be able to combine them, the denominators have to be the same. So our first step is to find the least common denominator so that we can begin to make these denominators the same. So in order to find the least common denominator, the first thing we need to do is we need to start with factoring. So we're going to take each of our denominators and we're going to factor them out. First step of factoring, no matter what type you're doing, it's always going to be GCF. So we have 3x squared plus 2xy minus y squared. Do you have a GCF? We have 3, 2, and 1, so no numbers. X squared, xy, and y squared, there's no letters that are the same in all of them. No numbers are in common, no letters are in common, so there is no GCF. Second step to factoring is you're going to look at your polynomial and say how many terms are there. So we have 3 terms. Anytime you're factoring a polynomial with 3 terms and there's no GCF, you're going to do the AC method. If there was a GCF, you take that out first. Then what's left inside the parentheses, you do the AC method then. So we're looking at AC is 3 times negative 1. 3 times negative 1, which is negative 3. B, so we have A, B, and C. B is your positive 2. Make sure when you're getting A, B, and C, it's in order alphabetically. So then we're going to make our chart, factors of AC, and the sum of those factors. If you want to see factoring in more detail, check out my factoring videos. So we're going to start with the number 1. 1 is the factor of every number. So 1 and what number multiply to make AC? 1 and negative 3. If I add those two numbers together to get the sum, 1 plus negative 3, gives me a negative 2. My goal here is this sum to equal B, while the factors multiply to make AC. We have negative 2, but we need a positive 2. If the only thing wrong is the sign, you're just going to go and change all the numbers, all the signs of all the numbers. So negative 1 and positive 3. If I add those together, I get the positive 2 that I want. What this tells me is these two numbers right here, I'm going to make a new B. So I'm going to undo combining like terms. I'm going to take my 2xy and make a negative 1 and a positive 3. Both numbers are going to get the variables from my original B. All I'm trying to do is undo combining like terms in a very specific way. So this is going to give me 3x squared minus xy plus 3xy minus y squared. A stays the same, C stays the same. The only thing that changes are your B's. Instead of positive 2, we have negative 1 plus 3. Same thing, we're just writing it a little bit differently. For the AC method, our next step is grouping. We now have 4 terms, so it is grouping. We're going to do the GCF. 3x squared and xy have an x in common. 3x squared divided by x is 3x. Negative xy divided by x is negative y. Over here, I have no numbers in common, but I do have y's in both of them. Since my first sign is positive, I'm going to make my GCF positive. 3xy divided by y is 3x. Negative y squared divided by y is negative y. Parentheses should be the same. If they're not the same, you've done something wrong. Most likely you took the wrong GCF out. If they're the same, you're going to factor that out. 3x minus y. x plus y would be left over. So that is this one factored out. So this factors to 3x minus y and y plus, or x plus y, sorry. Is that one factored? Yeah. So now I'm going to erase this so I can factor the other one. So my other denominator is 6x squared minus 5xy plus y squared. And we are focusing only on the denominators because at this moment we're trying to find the least common denominator. We'll deal with the numerators later, but at this point in time we want only the denominators to find what our new denominator needs to be. That way we can make them the same in order to be able to add them together. Same thing as before, we're going to factor. Your first step is always GCF. So if I look at my numbers, I have a 6, a 5, and a 1. So there's still no common factors number-wise in any of the three terms. If I look at my variables, I have x squared, xy, and y squared. So there's still not a GCF. Okay. My next step is how many terms do I have? 1, 2, 3. 3 terms is going to be the AC method. Same thing as before. AC is the first coefficient times the last coefficient, so that gives me a positive 6. B is the middle, negative 5. Again, make sure they're ordered alphabetically. X squared, xy, y squared. If we do our chart, I need factors of AC, and then I need the sum of those factors. So if I take the number 1, because 1 is a factor of everything, 1 times what makes 6? 1 and positive 6. If I add those together, I get 7. I want negative 5 for my sum. Since 7 is not negative 5, I'm going to go on to 2. 2 is a factor of 6. 2 and what number? Give me 3. If I add 2 and 3 together, I get positive 5. That's very close. We just need a negative, so we're going to negate all of our numbers. So negative 2 and negative 3 still multiply to make the positive 6. They add to make a negative 5. So these numbers are going to be your new B. Alright, so I'm going to leave A alone. 6x squared minus 2xy minus 3xy plus y squared. GCF for the first group, 6 and negative 2, that would be a negative 2 GCF, a positive 2 GCF, I'm sorry. Remember, it always takes that first sign. There's an x in both, so I'm going to factor an x out as well. 6x squared divided by 2x gives me 3x. Negative 2xy divided by 2x gives me a negative y. On this other one, I have negative 3xy plus y squared. GCF, there's no numbers, but there is a y. And it always takes the first sign. Since that first sign is negative, my GCF is negative. Negative 3xy divided by negative y is positive 3x. Positive y squared divided by negative y is negative y. That changes that sign. Parentheses are the same as they should be. If your parentheses are not the same, erase this entire step. Go back and redo it. Most likely you took the wrong common factor out. Since they are the same, I'm going to factor 3x minus y out. And that's going to leave 2x minus y left over. So that's the second denominator factored. I've got 3x minus y. 2x minus y. Okay. So your first step in order to find the LCD is to factor the denominators. That way we can get some sort of idea of what they have in common. That way we can see what would be missing in order to make them the same. So I'm going to erase this board again so that I can still use that to keep on working. Remember, this is video, so if you want to go back and see any part that's already been erased, you can rewind and pause. So we're going to work the LCD now. For our LCD, the way that I do LCD, and there's a bunch of different ways to do it, the way I do it is I write my entire first denominator down as a factored form. So my entire first factored denominator, 3x minus y, x plus y. It's the entire first denominator factored. Then I look at my second denominator, and I look at the first factor, 3x minus y. Do I already have a 3x minus y in my LCD? Yes, I do. Look at my second factor, 2x minus y. Do I already have a 2x minus y? No, I need another one, or I need one. The only time you should have multiples of the same thing in your LCD is if you have multiples of the same thing in one of the denominators. So if one denominator has two of the same thing, you need two of that same thing in your LCD. Since our denominators factors are both different, we should only have one of every piece in our LCD. So again, to recap, step 1, find your LCD. Our next step is going to be making equivalent fractions. Before I do that, I want to deal with this negative sign. Before I dive too much into the math, I want to deal with that because that's something students tend to forget quite often. So both our numerators are binomials. I'm going to go ahead and put those in parentheses just so that I can deal with them a little easier as I'm multiplying things to those numerators. I'm going to take this negative sign and I'm going to move it up and put it right there. That's going to get rid of it in the middle, make it a plus sign, put the negative at the top. That way you can distribute it and you don't have to worry about forgetting to do that step later on. So I'm going to go ahead and we're going to do that distribution. So if I bring down what I know, I have x plus y over here, and that is divided by, I'm going to write out the factored form, 3x minus y, x plus y. Keep that numerator in parentheses, that way you know to multiply and how to multiply correctly. So when we add something to that top, you multiply the entire numerator, not just one piece. For this one, I'm going to go ahead and do this distribution. -1 times positive y is a negative y. -1 times negative x is a positive x. Again, we're going to keep that in parentheses so that when I'm starting to put extra pieces in these numerators, I'm distributing the entire numerator, not just one piece of it. The denominator, again, factored form. I have 3x minus y times 2x minus y. So now I'm going to look at this first fraction. And I still cannot add these together because I can't combine fractions until the denominators are the same when I'm adding or subtracting. If you're adding or subtracting, those denominators must be equal. If they're not, you can't do anything until they are. So I'm going to look at my LCD. I have a 3x minus y, an x plus y, and a 2x minus y. And this first denominator, what am I missing? I have that one and I have this factor. But I'm missing the 2x minus y. If I were to put that down here as part of that denominator, then I would have the entire LCD as my denominator. That's what I want. However, we learned this rule earlier in algebra. What you do to one side, you must do to the other side. Talking about equations. It's the same thing when you deal with fractions. What I do to the denominator, I must also do to the top. So what I do to one side, I must do to the other. If I'm going to multiply it here, I also have to multiply it here. That way, in essence, I'm multiplying top and bottom by the same thing, which isn't really multiplying by just 1, because anything divided by itself is 1. Trying to get that denominator to be the same. So I'm not going to reduce it until the very, very end. Reducing is going to be my very last step. I'm undoing reducing at this moment. Looking at the second fraction, I have a 3x minus y And I have a 2x minus y. I'm missing that x plus y, so I'm going to multiply that into the denominator, so I have my entire LCD. What I do to one side, I must do to the other. Okay. We're going to leave our denominators factored. We don't want to change those. We're going to go ahead and multiply the numerators. So I'm going to write my denominators out really quick. 3x minus y, x plus y, and 2x minus y. If I were to multiply my numerator, I get x times 2x, it's 2x squared. X times negative y, negative xy. Y times 2x, positive 2xy. And y times negative y squared. For the second fraction, I should have the same denominator. They're not in the same order, but that's okay because they're all being multiplied. When you're multiplying, the order doesn't matter, just like 4 times 5 is the same thing as 5 times 4. So with the multiplication, it doesn't matter that they're in a different order. If I were to multiply my numerator, negative y times x is negative xy. Negative y times y is negative y squared. Positive x times positive x is positive x squared. And positive x times positive y is positive xy. Now that my denominators are the same, I can combine both fractions into one. We've done a lot of work to get that denominator. You don't want to lose it now. So I'm going to leave that denominator all the same, but I'm going to write only one fraction now. So I have 3x minus y, I have x plus y, and I have 2x minus y. And what I'm going to do with my numerators is I'm going to do a little bit of combining like terms to get those center ones worked out. So I have 2x squared. Negative xy plus 2xy is plus xy minus y squared. Negative xy plus xy, those go away. All right. I'm left with negative y squared plus x squared. Trying to put it into one fraction. Now that I have one fraction, I can go and combine like terms again. I have 2x squared and 1x squared, that gives me 3x squared. I have positive xy, that's the only thing I have like that. And then I have negative y squared minus y squared gives me negative 2y squared. Remember, combining like terms, you change the coefficients, not the exponents. That's all going to be divided by the same LCD we've been working with. Okay. We're not done quite yet, because always, anytime you're dealing with fractions, your last step should be to reduce. So we need to still see if this can reduce. So we're going to take this numerator and see if it can factor to something that has one of those three as a factors. If it does, we'll reduce those away and leave it with a more simplified form. So looking at this numerator right off the bat, I'm going to say there's no GCF. We have 3, 1, and negative 2. X squared, x, y, and y, so there's no common factors. I'm going to say AC is 3 times negative 2, that's negative 6. B is positive 1. If I make my chart, I have factors on one side, and I have the sum on the other. So I have 1 and what number multiplied make negative 6? That would be negative 6. If I add those together, I get negative 5. Not our B. We want B to be the sum. So I'm going to take the number 2. 2 is a factor of negative 6. 2 and what number? Negative 3. If I add those together, I get a negative 1. That's very close, but my B is a positive 1. So I'm going to change all my signs, negative 2 positive 3, add those together, I get positive 1, multiply, I'm still getting AC. So my new B, I'm going to have 3x squared plus 3xy. Leave my B, minus 2y squared. GCF, take an x out, leaves me with 3x minus 2y. GCF again, we have a y in both. First sign was positive, so there's going to be a plus sign in front of that y. Left over, 3xy divided by y is 3x. Negative 2y squared divided by y is negative 2y. Inside the parentheses are the same. 3x minus 2y. X plus y would be left over. So that's the factored form of that numerator. So I'm going to erase the factoring real quick so I can write this last step out. So I have 3x minus 2y, x plus y. That's being divided by 3x minus y, x plus y, and 2x minus y. Common factors, we need a 3x minus 2y. I don't have one, so I can't reduce that away. Or an x plus y. I do have an x plus y in the denominator, so those two could reduce because anything divided by itself is 1. So it can pretty much go away because 1 times anything is anything. And the numerator would be left with 3x minus 2y. In the denominator, we're left with 3x minus y and 2x minus y. That would be your answer. I cannot reduce any more. So just a quick recap. Your first thing we did was start by factoring. We found our LCD. Once we found our LCD, we got rid of the negative sign in the middle. We moved it to the top to go ahead and distribute. That way we could just deal with the plus sign and not have to worry about subtraction. Once we had our LCD as well, we made our equivalent fractions by taking whatever was missing from that fraction to make it look like the LCD and putting that in both bottom and top. We left the bottom factored. We FOILed or multiplied the top, then combining like terms and combining like terms again. Once we got everything simplified in that numerator, it's all in one fraction. We were able to factor, reduce to get our final answer. Okay. So that's adding or subtracting rational expressions. If it was adding, you would just miss this one step with the negative. That would be the only difference in adding rational expressions with unlike denominators. The only thing I didn't leave on the board was the actual process of factoring. So make sure you know how to factor because that is crucial to this problem. We had to factor 3 different times. Any questions? Please comment, send me an email, whatever you want.